To begin setup, the substrates were created and cleaned. Using a scoring tool to create a clean break line along the planes of the crystal, 2 cm by 2 cm substrates of silicon were created. Then, to clean them, they were sonicated first in acetone, then IPA. While the substrates were sonicating, a 10 cm diameter electrode was created using tinfoil. Care was taken to ensure the electrode was kept as flat as possible. Also, while the substrates were sonicating, the casing was assembled and external connections to the power supply, camera, and syringe pump were made. Once the substrates were clean and all connections were made, the substrates were dried using N2 and placed on the electrode, one directly underneath the needle and one offset. A flow rate of 0.0027 microliters per second was selected, which had the most success with generating stable Taylor cones in past experimentation. The voltage used was set to an approximate value when starting, 4 kilovolts, then adjusted for Taylor cone stability as the deposition continued. The Taylor cone stability was measured by viewing the needle tip and fluid through the camera and watching for the shape of the cone to appear as the voltage was adjusted very slowly. A final voltage of 4.45 kilovolts was selected, as this was a relatively stable Taylor cone. However, this cone was not perfect, exhibiting some drips that fell to the substrate below. In an ideal situation of electrospraying, there would be no drips at all, only electrospray droplets. This drippy behavior can be seen in the example footage, where the wavering of the cone is the drips being released. As a result of these drips, the voltage had to be adjusted from its equilibrium position at a few points over the course of the hour-long deposition. If the cone was disrupted too much, the voltage would be brought down until enough fluid connected at the tip, then brought back up to the equilibrium voltage to start spraying once more. After the deposition was complete, the sample was taken to the ellipsometer to measure the thickness of the deposited films. The film was measured in 3 separate places using folded painter's tape to cover the areas that were not being measured. There was a dense region where the drips had landed and extreme coffee ring behavior was exhibited, the middle region where particles were deposited more evenly, and a sparse region where only a few particles were deposited.